So in this module, we are going to discuss about some of the applications of UDP. So till now, we have discussed that UDP is an unreliable service, right? Then also, why do we use this UDP? Because of its speed. Okay. And all these applications are indirectly dependent on speed. So whatever applications which uses UDP needs speed. Okay, they are in need of speed. See, first of all is the connectionless service. So as we have discussed in previous modules, that what is a connectionless service, what is a connection oriented service, right? We have discussed it. Then in that, why actually UDP, how can this advantage towards the UDP see here? See, there is one application layer protocol named as DNS, that is domain name server, domain name service. Okay, so what actually it does is, it suppose this is your computer. Okay, this is source and this is the receiver. Now on your Google Chrome, when you write google.com, okay, it actually, what happens actually is, it goes to the domain name server, that is DNS, and whatever you have written google.com, there will be a corresponding IP address present over there. It will retrieve that IP address, and then that packet would be reaching that respective server. Okay, this is the whole process. Now in this process, if you waste time, see, this is the short process. Okay, I'm calling this process 1, this is process 2. Suppose you waste time in process 1 only, then this is not feasible, right? Your original packet is in process 2. Therefore, in order to complete this process 1 faster, at a faster speed, you make use of UDP. Okay, that is short request and shorter response. Okay, this is what you get using UDP, right? Therefore, you need an shorter request. Yeah, this is my google.com. I need the IP address corresponding to google.com. This is what you say from this side, and from the DNS side, you are going to get its respective IP address. Okay. Now, next is lack of error control. Okay, how this features advantages, how this feature is advantage to an UDP here. See, suppose this is mostly used in real-time streaming. Okay, real-time streaming of videos, audios, all those stuff. Okay, in that time, see, suppose you are watching some video. Okay, this is some video. Okay, which you are watching. Now suppose instead of UDP, I take TCP. Okay, I use TCP. In that case, what happens is, your pixel would be continuously flowing. Okay, now suppose these many pixels are coming in incorrect order. Now suppose this pixel has been lost. In case of TCP, it is going to retransmit the same pixel again. Till that time, you will have to wait. Okay, you will have to wait means the whole screen becomes blank. Your screen will be blank for seconds until the last frame is not being retransmitted by TCP. Okay, therefore you don't need an blank screen, right? Whenever you are watching something, whenever you are watching some video or a movie, what if some disturbance happens? That's not feasible, right? You won't like that kind of disturbance. Therefore, you use UDP. With Even if one of the pixel is missing, it is not going to hurt you anything, right? Even if one of the pixel from the whole screen is missing, you will not even observe that change. Okay, you will not even observe the missing pixel, right? It is very hard. Therefore therefore in case of video streaming, online video streaming and all those stuff, we make use of UDP because of this blank screen problem. Okay, now is the broadcasting and multicasting purposes. So UDP is also used for broadcasting and multicasting purposes. So we have studied what is broadcasting, and we have also studied what is multicasting. Suppose this is one node. From this you have to broadcast to each and every you have to broadcast the packet to each and every nodes. In that case it is broadcasting, right? Now if I use TCP, what if I use TCP? In case of TCP, I said there is an buffer, window buffer at the sender side. There is an receiver buffer at the receiver side. This is receiver 1, this is receiver 2. There will be an receiver for receiver 2, and there will be an buffer for receiver 2. From the sender, this is 3 3. So suppose I have to send broadcast this to 100 of these nodes, receiver nodes, then it is not feasible, right? Because at your sender side you're just accumulating this sender window, okay, sending window. You're just going to increase the computational power. You are going to take most of the computational power at the sender side, right? Because of this window. Therefore, in case of broadcasting or multicasting purposes, instead of using an TCP, you are going to make use of UDP. Why? Because there is no as such concept of windowing, right? There is no concept of windowing in UDP. You have to send some packet to this receiver R1, you just use UDP. You just send the packet directly instead of just making these windows and all those stuff. Okay. Next, UDP is also used in routing information protocol. So, what is routing information protocol? We have studied this in routing. Okay. Now, in next thing we are going to study about next module we are going to study about UDP packages. Thank you.